Hello everyone, welcome to Geoscience Engineering. In the last videos, we have discussed about what are seismic waves and the basics about the earthquake, and then basics about the instrumentation and also the installation part of the seismic equipment. Those videos are uploaded in the seismology playlist. So if you didn't see this, you can have a look at them. Now today we'll discuss about seismic waves and the wave propagation. In this particular video, I'll give you the introduction about what we are going to discuss, and in the coming videos I'll show you the practical and real-time data and related to these seismic waves. So we'll discuss about the seismic wave types. We have been discussing about these seismic wave types in almost all the videos, but I'll go in detail and also show you the practical from a real-time data source. So example, I'll take the data from the earthquake, and then I'll show you the P waves, the S waves and the surface waves, and then we'll go for a little introduction about the elastic rebound theory and how this can be used particularly during the earthquake monitoring. Then we have the classification, and then we have the body type, body waves, P waves and S waves, surface waves, love waves and Rayleigh waves. So in this, the particle motion is very important. I'll take one real-time earthquake data, and then I'll show you the particle motion, how the earthquake will impact the particle. So when the earthquake is in vertical direction, the particle moves up and down, and it's in north and south, east and west. So I'll practically show you the particle motion, how does it move, and we'll also discuss about the S waves, then the surface waves, Rayleigh waves, and most important, we have to discuss about the wave parameters, because when you go for an earthquake study, you need to find the amplitude and also the velocity and other properties of the seismic waves. So we'll discuss about amplitude, and then how to measure the amplitude, and what kind of softwares are used to directly give you the maximum amplitude value, and then the velocity. All these parameters will be discussed in the coming videos, and then I'll discuss only a little about the reflection and refraction, but this is mostly used when you are going for the phase studies. So I'll also explain about the phase diagram, so you can clearly understand what is reflection and what is refraction. And then we'll also go for the Snell's law and the ray theory, and then this travel time or time travel curves are very important in identifying the epicenter or the hypocenter. I'll take some real example from the USGS or some real-time data, and then I'll show you how the time and distance are calculated, so used so that we can identify the hypocenter of the earthquake. And then the attenuation and dispersion, I've already made a video about the attenuation, but I'll also explain you in detail about this when we discuss about the microzonation. And this is the seismic phases. This is very important because this is used to map the Earth's internal boundary, like the Moho discontinuity and the core and other kinds of discontinuities in the Earth. And then we'll go for the wave polarization. This is very important because it will help you in identifying the source mechanism and fault orientation, because earthquakes are generally energy that is released from a fault. So we wanted to know where and which direction the fault is, or from which direction the source has come. So I'll tell you how this wave polarization will work, and then I'll also give you a brief introduction about the interference and resonance part, and then the site effects and the amplification also, and the wave propagation inside the earth. That means how these waves are bending with increasing depth due to velocity gradients and all. And we'll also go discuss about the S wave shadow zone, P wave shadow zone and all. And then finally we'll discuss about applications in seismology. This is generally a very short application, but I'll take some case studies and I'll explain you in detail about the applications in seismology. So in the end, by the end of this video, next video you will be knowing about seismic waves for both structure and source information, classification of body and surface waves, wave properties determining the time travel and energy distribution, and also understanding the propagation is key for earthquake studies. Thank you.